This is Geometry 1.5a, talking about the Pythagorean Theorem. So the Pythagorean Theorem is the square of the lengths of the hypotenuse. The hypotenuse is across from the 90-degree angle. That's the identification of where the hypotenuse is. And when we square the hypotenuse, that's going to be equal to the sum of the square of the legs. And the legs are the sides that are perpendicular to each other. So our formula is hypotenuse squared equals leg squared plus leg squared. Many of you probably think about it with the letters. A squared plus B squared equals C squared. Or you can write the C squared first, which that's what I would suggest you to do. Write the C squared first. And C squared equals A squared plus B squared, because that'll help us with some calculations in the future. So that's Pythagorean Theorem. This should be a bit of a review. So when we come down, we are looking for one side of a right triangle. Notice what information we have. We know it's a 90-degree angle because of the box in the corner. That's called a right triangle. If we're working with a right triangle, and we know two of the three sides, we can solve for the missing side. We're going to use Pythagorean Theorem. So I like to write the Pythagorean Theorem not with the A, B, and C, but with the hypotenuse, leg, and leg. It's more specific when we write it with hypotenuse squared equals leg squared plus leg squared. When we use the A, B, and C, sometimes we don't know where the A, B's, and C's are. Or what if our problem actually has an X and doesn't have a C? It gets confusing where it goes. So when we write it using hypotenuse, we know the hypotenuse is across from the 90 degrees. So that's going to be on this side. The legs are the ones that form the right angle. So these are your legs. So actually label it in your picture. So your hypotenuses are unknown. That's where we put our x squared. Then we have our 7 squared. I often put the smaller number first. And then we have the 24. Those are your two legs. It really doesn't matter what order you put the 7 and the 24. You can put the 24 first. So 7 times 7 is 49. And 24 times 24 is 576. That's a big perfect square. So then, algebra says we're going to collect our like terms. So we have x squared equals 625. Now we've got a decision to make. How do we get the x by itself? Right now it's x times x. It's x squared, which means x times x. Two numbers multiplying each other to make 625. We would take the square root. So that's where this comes from, why we spent a day working with radicals, because now we are applying some of that radical work here. So we're going to have x equals, now the square root of 625, what number times what number makes 625? It is 25. Now let's take a look over here. If the hypotenuse is 25, there's some rules about a right triangle. The hypotenuse has to be the longest side. So be sure that your answer makes sense. If you're solving for a leg, it has to be smaller than the hypotenuse. If you're solving for a hypotenuse, it has to be larger than the legs. So that's one way you can help be sure you're picking a reasonable answer. Here's another little hint about all right triangles. The two legs will always add up to be more than the hypotenuse. So when they add up and they're adding up, it looks like, to 31. We know the hypotenuse has to be smaller than 31. So if you get an answer like 625, that doesn't make sense. It's way too big. The 7 and the 24 would never swing down to make a triangle. It wouldn't make the 625. So be sure your patterns make sense. The hypotenuse is the longest side, and the legs will always add up to be more than the hypotenuse. All right. We move on to our next question. We must be running from the zombies because we need to put a board underneath the door handle to keep the door shut. I can't imagine another reason you need to do that. So, okay, hysterical, thank you. So we have the board underneath the door handle. I'm going to redraw this right triangle. It has a right angle. We have 5 from the door. The board itself is 6. What we don't know is the height of the door handle. Now, pay attention. This is super important. What side is the hypotenuse? It's the one across from the 90 degrees. It is the longest side. It's always across from the 90 degrees. So that makes the other two sides, the perpendicular sides, those are the legs. So I like to label that in my picture. It gets me to think about it. It gets me to pay attention. It shows some work. So when you start out with your formula, hypotenuse squared equals leg squared plus leg squared, I would expect you to write that in your work. You may use the letters if for some reason you're hooked into using A, B's, and C's. You're welcome to do that. But I do feel this is going to be a better shot for anyone that's going to be making a mistake in identifying the wrong side with the wrong letter. So the hypotenuse is your 6. So notice what I just did. I put the 6 with the hypotenuse. This is where a lot of people make a mistake. They always put the unknown in that location, and that's not true. You need to put the hypotenuse in that location. That's why we name it hypotenuse. And then your leg, and then the other leg. The two legs go in the leg spot for the formula. Now it's just the algebra part. You might like the geometry part. That's what we just did. That's the geometry part right here. Now we're going to do the algebra part, which is 36, 25, and x squared. When you square 6, you get 36. When you square 5, you get 25. 5 times 5 is 25. So now we're going to subtract the 25 over, and that gives us 11. So we need a number times a number, x times x. That's what x squared means, x times x. And that makes 11. So 11 isn't our answer. Think about it. If we said this was 11, 11 is bigger than the hypotenuse. That's not going to work. So 11 isn't the answer. What do I need to do to... You had the answer last time? Square root it. So the square root of 11 equals our x. Anybody have an idea approximately what the square root of 11 value is? Just any idea. Would you want to make the square root of an 11 if you were making money? Is that a lot? Is that a little? Square root of 11. What is the square root of 9? Square root of 9 is 3. So this is bigger than the square root of 9. So this is bigger than 3. This is smaller than the square root of 16. So this is smaller than 4. So this is between 3 and 4. See how we just did an approximation? This is a value in between 3 and 4, and that would make sense. If this was between 3 and 4 and you add it with the 5, that would be greater than 6. But 6 is bigger than both of those numbers. So it's a reasonable answer. You can circle your answer. Now here's the toughest problem we probably have when we're working with the area of an isosceles triangle. When we have an isosceles triangle, it tells us that two sides are the same. In an isosceles triangle, we typically put the congruent sides, the ones the same length standing up, and the base on the ground. So there is your base. There are your 17s. To find the area, we need to use half of the base. Well, I have that. What I don't know is my height. Base times a height. Half a base times a height. So I need to figure out what the height is. The height is not 17. That's the common mistake. People want to use 17 as your height. So we're going to need to solve for the h. So I'm going to redraw this triangle. When we draw our line down in an isosceles triangle straight down, it's going to be 90 degrees with the bottom, and it's going to cut it exactly in half. It's called an altitude. An altitude is 90 degrees, and it's a median. It cuts the triangle in half. So we have 8, we have 17, and we have this height that we're not sure what it is. We have a right triangle looking for one side length. So we're going to be able to use hypotenuse squared equals leg squared plus leg squared. And plug in our numbers. So our hypotenuse, remember, is across from the 90-degree angle. That's our hypotenuse. That means the other two sides, the perpendicular sides, those are your legs. So that's why I put the 17 under the hypotenuse and the 8 and the h underneath the legs. So you need to set up your formula correctly to give you a chance to calculate this. So then we get 189 when we do 17 squared, or 289. 289, 64, and h squared. When we subtract our 64, we get 225. What do I need to do? We need to take the square root of both sides, and that would be 15. So the height of your triangle is 15. How is that going to help me with the area? The area of a triangle is half a base times a height. So they asked for the area of the triangle. The base of the triangle is 16. And the height of the triangle is 15. So you can either take half of the 16, or you can take half of the 15, or you can multiply the two together. So it might be easier for you to work with smaller numbers and take half of that 16. So I took half of it. Now I have 8 times 15. And in your calculator, 8 times 15, that gives us 120. So 120, these are meters squared, or square meters. That's the area of our isosceles triangle. That's a tough one. We had multiple steps to do there. Number one, we had to figure out the height. Number two, we had to plug that height into the area formula of half a base times height. Two more examples we have here on the back side. Nothing new except what a Pythagorean triple is. A Pythagorean triple is a set of numbers that is going to satisfy hypotenuse squared equals leg squared plus leg squared. So in all these cases, if you take a look, 39 squared is a really big number. But if we take 15 squared and we take 36 squared, we expect that to equal that same super big number. These are all integers, or actually whole numbers because they're positive. The common ones that we need to be aware of are definitely the bold ones. This is going to help you on the SAT and the PSAT. If you know your Pythagorean triples, you don't have to do so much of the Pythagorean theorem. You can recognize if they give you the number 3 and 4 that the missing side is going to be 5 if it's following a right triangle. So coming down here, there's a couple different ways we can do this. You could solve for the missing side by just doing the Pythagorean theorem. That's what I'd expect you to do. But if you think about it as their patterns, if this was 30 and 40, what pattern is that following up here in the gray? Which one is that kind of like? 3 times 10 is 30. 4 times 10 is 40. So 5, what do you think the missing side is going to be?
50.
That's going to be 50. That's a quick way to help you calculate what that missing side is if you know your Pythagorean triples. And this last one, if you reduce those down, divided by 2 and divided by 2, what's your Pythagorean triple up there that has a 24 and 25?
14.
And you would have to double it to get 14. So that's kind of a neat way, if you understand your Pythagorean triples, you can save the extra calculations. But Pythagorean theorem always works. You can do the full calculation.